Back to Educator.com, Introduction to C++. Today is our second part discussing functions. We're going to talk about types of parameters, the kinds of parameters that you can pass in. We have call by value, call by reference, call by address. There are default parameters available. And we'll mention again about getting a single return value unless you use one of these call by reference parameters, and how to overload functions, and a brief discussion of how functions are better when you make them small and isolated. We're trying to make it as independent of your application as possible. The parameters by value is your arguments go into the function and they don't come out. I don't want to give the joke about the Roach Hotel because that's not nice. But the function, by virtue of the fact that it does not come back out, the function might change the values that come in. So basically what will happen is it will make a copy of the values of the arguments that get passed in. And this is safer from the perspective of increasing your modularity, increasing your independence from the rest of the code. So here's a quick example. We're going to multiply by add. Rather than using the asterisk, we're just going to say, well, 3 times 7 is 7 added 3 times. So we're going to pass in a 3, we'll pass in a 7, and we will loop through here 3 times, starting at 0 and ending before we hit 3. So 0, 1, 2, and we will add second to itself. So you'll have 7 plus 7 is 7, that'll be 14. Second time, 7 will be added to that again, and it'll be 21. And this code is actually broken. It will give me the wrong answer. You'll add 7 one more time, you'll get 28, which is 4 times 7. So there's another homework assignment, is to fix this code so that it works correctly. But the point being, now it returns the calculated value. Now this parameter is what was passed in. And the function, since it's called by value, the function is free to change the value of this variable as much as it wants, as much as it needs to. There's no fear that you mess up the calling program any kind of way. Your next way is call by reference. Now when you have a call by reference, you include the ampersand between the type and the name of the parameter. So now in this case, if the function changes the value of this parameter, it's reflected in the caller's value. This is a way of getting more than one variable output sent back to the caller, because you can put as many of these on your parameter list as necessary. Now, one restriction, of course, is you have to send it a variable. You can't send it the return from a function. You can't send it a literal value, because how can you take a literal value and then change it? You can't. It's a constant. So it's useful for returning more than one value. I'll give a quick example here. You have f int a. So now you can change a. Now, you cannot call it with 5. How can you change 5? But if you have a equals 5 and then call it with a, that's fine, because now we have an actual variable whose value can be changed. And here we have an example. We've got a change to our functions from before. We have a function calculate total area, which has variables passed in by value. All it does is multiply width by depth and returns that. Now we have here calculate useful area. We have not only the width, the depth, and the easement. There's a couple of things that we want to pass back to the caller. We want to pass back the total area, and we want to take a calculation of the percentage that the easement is. If it's 1 foot, that's 1% of 100 foot. If it's, is it 50% of your lot? So this returns to the caller some value of how much easement is there. So what we have here with total, very simple. We're calling this function to get the total. The percentage is the easement divided by the depth times 100, which makes it into a percentage. And then we're returning the width times depth minus easement, which was the original calculation before we added these 2 extra parameters. And here's an example of an error, because 17 and 10 have to be variables. You have to call this with, let's say we have, these are floats. So we'll have float T for total, and we'll have a float EP for easement percent. So now we can call this, instead of setting 17, we'll pass it T. Instead of 10.0, we'll pass it EP. It will do its calculations as before and return back to the caller a value for T and a value for EP, which it can then print out. It says, okay, this is the total area, and this is the percentage used by the easement. Now, another type of parameter is a default parameter. This is where a caller doesn't need to provide a particular argument. The function says, well, if you don't give me a value for this parameter, I'll use a default. So the function uses a default when the argument is not provided. Now, one thing to be careful of, if you send it more than 1, if you put 1 in the middle, then everyone after that has to have a default, because the compiler has no way of knowing that this is supposed to be the 3rd default value that's being passed in. So here's an acceptable example. We're defining this function f, integer a, integer b, integer c. The default value for c is 1. The default value for d is 1, and the default value for e is 1. This you cannot do, where you put a default value here without a default value following it. So once you put a default, everything after the default must also have a default. So here's an example using a default. We're going to calculate the useful area. We'll have a width that has to be passed in. A depth, if you don't give it a depth, we'll use 200 as the default. And the easement was, well, if you don't give me an easement, we'll default that to 30. And we'll do our calculations just like normal, except if we call it with just the width, well, then the depth will be 200, and the number of easement feet will be 30. Now, if you want to add another value, you can add a depth. So we'll have width, and we'll pass a depth, because you've got a depth that's 210. But we're still using the default of 30.